Question 33 asks us to analyze the circuit pictured on the left and find what the charge is through the capacitor and what the current is through the resistor at various times. Part A asks us to find those values when the switch is closed. To do that, we first start out with finding the charge of the capacitor. To find the charge of the capacitor, we use this Q is equal to CV we learned in lecture a couple days ago, where we have the charge on the capacitor is 4 microfarads times the 9 volts, which gives us a value of 36 microcoulombs. Next, we need to find the value for the current through the resistor. To find that, we must employ Ohm's law, which says V is equal to IR, and solve for I. So now we have I is equal to V divided by R, V being the 9 volts over to the left, and R being 25 ohms, which is this resistor here, which will give us a value of 0.36 amps. Part B asks us to find the charge through the capacitor and the current through the resistor at time t equals 50 microseconds. To do this, we need to start by finding the time constant, which is tau equals resistance times capacitance, which will give us a 25 times 4 microfarads, which is equal to 100 microseconds. Next, we need to plug it into this formula here, where Q is equal to Q naught times e to the power of negative t divided by tau. Substituting in, we have Q is equal to 36 microcoulombs. That value is found in part A, times e to the negative 50 microseconds, which is just the time, divided by 100 microseconds, which is the time constant, which will give us a value of 22 microcoulombs. Next, we need to solve for the current. The problem goes along in very similar to the charge. We have I equal to I naught e to the negative t over tau. So we have I naught from the last problem as just 0.36 amps. This is I equals to 0.36 times e to the negative 50 microseconds divided by 100 microseconds, this being the time in question and this being the time constant, just like finding the charge. This in turn will give us a value of 0.22 amps. Part C asks us to find the charge through the capacitor and the current through the resistor at t equals 200 microseconds. To do this, we do the exact same thing we did in Part B, except we use a t value of 200 microseconds instead of the 50 microseconds. So we have Q naught times e to the negative t over tau. Q naught being the 36 microseconds, t being this given here, and 100 microseconds being our tau value, which we calculated by multiplying the resistance by the capacitance. Now we have 36 microcoulombs times e to the negative 200 microseconds divided by 100 microseconds, giving us a value for Q being 4.9 microcoulombs. The resistance is solved in the exact same way, except for we switch Q for I, Q naught for I naught, and that's about it. So we have I equals 0.36 amps times e to the negative 200 microseconds divided by 100 microseconds, giving a value of 49 milliamps. And that's it.